In this demonstration, we dropped a 220-pound mannequin only 6 feet. When the mannequin hits the bottom of its 6-foot drop, you can see the violent forces at work. Now, look at the difference when you incorporate a shock-absorbing lanyard. The forces on your body have dropped from almost 5,000 pounds to less than 900. And there are many different types of fall protection systems to consider. From horizontal lifelines to vertical climbing systems, basic fall restraints to self-retracting lifelines. All of these fall protection systems are designed to fill specific needs. This could include engineering out the hazard, like moving a valve to ground level, or simply installing guardrails. But if a possibility of falling still remains in your work environment, you need a fall arrest system, a system that brings you to a safe stop when you fall. And no matter which fall arrest system you use, they all require some fundamental considerations. This is where we'll focus our discussion. Your fall arrest system must include the following components: your harness, what you wear; connectors, what's attaching you to your anchorage; the anchorage. Your anchorage is the structure you're attached to; and, of course, a rescue plan.
When you set up a fall arrest system, there are several things to consider. These are arresting forces, which are forces generated on your body and the system when you fall; required clearance, which is the distance you must have between your work platform and the nearest obstruction below you; and swing fall, which is the pendulum-like motion that can occur when you fall.
In this demonstration, we dropped a 220-pound mannequin only 6 feet. When the mannequin hits the bottom of its 6-foot drop, you can see the violent forces at work. Let's take another look in slow motion. The amount of force generated on that 6-foot drop is measured at almost 5,000 pounds. That's more than enough force to cause serious injury. If you're using a 6-foot lanyard connected to the dorsal D-ring of your body harness, and you connect the other end to an anchorage point at the same height, how far will you free fall? In this case, you'll free fall 6 feet, because that's the length of the lanyard that's connecting the 2 points together. However, how far will you free fall if you're connected to an I-beam 4 feet below your dorsal D-ring? In this case, you'll see a free fall of 10 feet. That's 4 feet to the I-beam plus the 6 feet of lanyard. Here you'll have exceeded the typical 6-foot free fall. To determine whether we have enough clearance below us, we must add our free fall distance plus our deceleration distance, the distance it takes for our system to slow us down and stop us. During deceleration, the system makes use of a shock absorber that will dissipate energy as it tears open and stretches. This process of slowing us down increases the length of our total fall distance. Regulations state that the deployment of a shock absorber may add a maximum of 3.5 feet to our fall distance. In addition, as we decelerate, our D-ring will slide up on the harness, and our body will form into the harness. This will add 1 additional foot to our deceleration distance. In total, deceleration adds 4.5 feet to our total fall distance. So, in this application, our total fall distance is 10.5 feet. And finally, we need to add a safety factor. The safety factor that we often use is 2 feet. Now we have our required clearance, the clearance we must have below us in case of a fall. It totals 12.5 feet when using a 6-foot shock-absorbing lanyard connected to our dorsal D-ring and anchored at shoulder height. A swing fall can occur when you position yourself to the side of your anchorage point. In the event of a fall, your fall arrest system will stop you. However, due to the angle, you'll swing like a pendulum. potentially striking any objects in your path. The greater the angle from your anchorage, the wider your swing fall will be, and swing fall can cause serious injuries. With a full body harness, we're able to protect the body by distributing the fall arrest forces over the thighs, buttocks, chest, and shoulders. When donning the full body harness, it must be adjusted to fit you properly. It should be snug but comfortable. The subpelvic strap should be positioned directly under the buttocks. This strap and its proper placement are crucial. It is the subpelvic strap that dissipates much of the energy generated in a fall. The chest strap must be fastened securely, and the dorsal D-ring should rest between your shoulder blades. Once your full body harness is properly fitted, you'll get freedom of movement, comfort, and maximum protection in a fall. They're available in a wide variety of shapes and sizes, and must all be self-closing and provide a locking feature to help reduce the possibility of rollout. Like connecting two snap hooks together is not safe. See that? Or using incompatible sizes. Make sure you always use a D-ring that is larger than your snap ring to prevent forced rollout. Of rope, webbing, or cable. When used for fall arrest, they must include a shock absorber. Here's why. As we saw earlier, a 220-pound, 6-foot drop generated almost 5,000 pounds of force on the mannequin. Now, look at the difference when you incorporate a shock-absorbing lanyard. The forces on your body have dropped from almost 5,000 pounds to less than 900. Something else to consider with lanyards. Never tie knots or run them over sharp objects. This will greatly reduce the strength of the lanyard. Vertical mobility with lanyard connectors is something else that's important. Since most lanyards are only 6 feet long, they may not provide you with enough vertical mobility to do your job. Rope grab and vertical lifeline systems, or self-retracting lifelines, are other types of connectors that allow you to have greater vertical mobility along with added protection. The most important thing to remember with connectors is to stay connected. If you're not connected, you're not protected. To use an anchorage point that is not certified, ask yourself, is that anchorage point able to support at least the weight of a full-sized pickup truck? If you don't think so, don't use it. Now, with that in mind, some obviously inappropriate anchorages would include fluid carrying pipes, electrical conduit, or handrails. It's also important to remember that the rescue should be kept as simple and safe as possible. If calling 911 is your only rescue plan, then you must ensure that your local rescue professionals have the equipment and training required to perform your rescue. While checking your equipment, be sure all the hardware is free of cracks, burrs, or corrosion, and all the working parts move freely, including the buckles and snap hooks. Be sure that all the plastic pads and keepers are in place and free of cuts or cracks. The webbing and rope should be free of any cuts and frayed or broken fibers. Check for tears, abrasions, burns, or discoloration. All the stitching should be intact. Check for pulled or cut stitches. Broken stitches may indicate that the equipment has been impact loaded and must be removed from service. Inspect all the labels to see that they're present and fully legible. If the labels are not, they should be replaced.
Upon final inspection, record the results and date in an inspection log. If the inspection reveals any defective component, remove it from service immediately.
The term fall protection encompasses everything we do to protect someone while at height.
And working at height means 4 feet or more for industrial applications and 6 feet for construction.
If the possibility of falling exists in your work environment, you need a fall arrest system. A system that brings you to a safe stop with 1,800 pounds or less of arresting forces. A fall arrest system will have 4 components: an approved full body harness, connectors, including lanyards, shock absorbers, self-retracting or vertical lifelines, and rope grabs, anchorages. Only suitable structural connection points should be used as an anchorage, and they must be capable of supporting 5,000 pounds per worker attached. And finally, a rescue plan. Always have a rescue plan.
When using a fall arrest system, always consider the following. Determine your total fall distance. This includes your free fall distance plus deceleration distance. Now, add your safety factor and you have your required clearance. Finally, the positioning of your anchorage affects your free fall distance and your swing fall. Remember to keep your anchorage as close to directly overhead as possible.
All your fall arrest equipment needs to be properly maintained. You should personally check all your components thoroughly before each use.
And don't forget to log those inspections. Also, be sure to have an annual inspection performed by a competent person.